In this video we are going to explain you about the double integration. Okay, so how to go on with the double integration. So we have this. Now the question, we are going to solve one question here. So the question here is how to solve the double integration. Okay, so we have this question 0 to pi, and from 0 to a1 plus cos theta. The function here is given to be r dr d theta. Okay, so first of all, the first dr, the first integration is with dr, the whatever this limit 0 to a into 1 plus cos theta is a limit for dr, and the limit for d theta is 0 to pi. Okay, 0 to pi is the limit of d theta. So we'll try to integrate this. So if we integrate this one, let us try to integrate this with respect to dr first. So if we integrate this with respect to dr, we get here r squared by 2. And the limit is 0 to a 1 plus cos theta d theta. Okay, so here we can take 1 by 2 common, is outside the integration, and we have 0 to pi. Okay, 0 to pi. Try to, it will put the upper limit first. So we have here a 1 plus cos theta whole thing square minus 0 square d theta. Okay, so we are getting this as this one. So this is equal to 1 by 2, 0 to pi. Here we get a square 1 plus cos theta. Okay, 1 plus cos theta is nothing but it is 2 cos square theta by 2 whole thing square. Okay, d theta. So we get here this. So here we have this one can be written as a square by 2, 0 to pi. Here we get as this will be 4 cos to the power 4 pi theta by 2 d theta. Okay, so this and this get cancelled, so we get here 2a square. Okay, we get 2a square 0 to pi cos 4 theta by 2 d theta. Okay, now we want to integrate this, so we'll try to do by elimination here. We'll try to do the elimination method here. So this substitution, we try to do a substitution here. So you take phi to be equal to theta by 2. Okay, then d phi by d theta is equal to half. Okay, if we differentiate this, so we get 2 d phi is equal to d theta. Okay, 2 d phi we get d equal to d theta. Now we have to change the limit also. So when theta equal to 0, we have to find what is phi. So we'll put here theta 0. So we get phi also to be 0. When theta is equal to pi, you put here pi, we get phi to be equal to pi by 2. So the limit changes from 0 to pi by 2. So we have here 2a square 0 to pi by 2, 0 to pi by 2 cos 4 phi 2 d phi. Okay, you get this. So this is equal to 4a square 0 to pi by 2 cos 4 phi d phi. Then by reduction formula, we have the reduction formula for this. By reduction formula for this, the reduction formula is given by integration 0 to pi by 2. Suppose I take this as jn is equal to, this is 0 to pi by 2 cos nx dx is equal to n minus 1 divided by n j n minus 2. So this is your reduction formula. We are going to use this reduction formula here. So we get here as 4a square. We'll use this. So n is 4 here. So 4 minus 1 by 4. J here is j. 4 minus 2. We get here 2. Okay. So again, here we have this and this get cancelled. So we get here a square 3. Then here 4 minus 2 we get 2. So we can again apply this formula. So if we apply here, now n is 2. So 2 minus 1 by 2. J 2 minus 2 we get 0. Okay. 2 minus 2 we get here 0. That is equal to nothing but we get here 3 by 2 a square. We have here 0 to pi by 2. J0 means cos to the power 0 phi. Cos to the power 0 phi is 1. So we are getting here only d phi. Okay. So we get here d phi, which is equal to, we get here 3 by 2 a square phi, and we have to put the limit 0 to pi by 2. So if we put the limit here, we get the answer as 3 by 4 pi a square. Okay. Thank you.